Alright, another DraftScience video presentation. Continuing the kinetic energy saga story. So exhausting. The same mush over and over again, and no evidence at all. So, all these people keep telling me what science says, what the science truth is, and yet they can't provide a single piece of evidence. Nothing. Zero experimental evidence. Nothing. Except Stephen Bro's experiments, which is sort of another whole saga of bullshit. Because they weren't conclusive and they did contradict each other, and so what do you make of it? Well, you make of it that the experiment isn't that easy to do. You do have to do it carefully. If you're going to attempt to measure energy, you're going to have to do it in some kind of scientific way. Okay, yeah, you're going to have to make sure you're measuring the right thing, that what you're using to measure with is the right tool. The ruler just doesn't come free. So, on that subject, I will do a little physics first, that's the way it should be. I have a number written down here, 2.27. Okay, so I'm still the Stephen Bro. Anybody who has one of those little scales, they're just a little piece of plastic thingy, and it's got a little scale on here, little notches. And, I used to have one, and it measures like things under a couple of pounds. But that's what we need. We need somebody to drop a stick of butter, okay, so a quarter pound. We need them to drop it 1 meter and see how much the maximum scale reading is. So videotape the scale, drop the butter this way, maybe this way. Obviously use like really cold butter so it doesn't deform, and try to get the heaviest reading from 1 meter. Don't throw the butter, just drop it. And then we'll know what a joule weighs. Right, and then we can just put it into pounds. Now I'm thinking it's going to be around 1 pound, frankly. It's just going to turn out that way. It doesn't turn out to a kilogram. It just turns out to be a pound, very close to a pound. It's basically 4 times the weight when something drops a meter. Now, I can't say because I don't know that one. Okay, so if somebody knows the answer, that would be great. After something drops 1 meter, the velocity is always the same. So the velocity is calculated to be 4.4 something 76 or something. Anyway, so that's the velocity of traveling 1 meter in gravity. So that's what a joule is. A joule is a stick of butter falling 1 meter. So I'd say it's pretty close to a pound, but we'll find out. Eventually, somebody will do the experiment. This one shouldn't be too tough for physics. I mean, it just sort of amazes me that nobody's done it, as far as I can tell. It hasn't been done. It's so simple. I mean, how could it not have been done? So anyway, I probably should have more light on, but fuck it. Yeah, I don't care. It's good enough. So what I have found is that to do the calculation, so we know the stick of butter is 1/10, okay, of a kilogram. That's a Newton, okay, and you just multiply that times a stick of butter. So a quarter pound is the same as 1/10 of a kilogram. Yeah, and so you multiply that times the velocity, which is 4.4, whatever, blah blah, and so that comes out to 447, whatever, blah blah blah, and then you multiply that times this number, and that'll give you 1. That'll give you 1 joule. So this number will convert momentums. Okay, so whenever you have the mass times the velocity, you just multiply it by 2.27, and that will equal a joule. So there's a formula for you. Okay, so they put them in boxes. Okay, so it's just the mass times the velocity times 2.27, and that'll tell you how many joules. You can convert the momentum now directly into joules. So if you want to convert momentum, quality of motion, as Newton would have called it, into joules, because Newton didn't know what a joule was. They weren't invented until the 1800s. But if you want to convert momentum into joules, just multiply the momentum by 2.27. And that'll tell you how many joules of energy is represented in the force that created the momentum. And that's the way it works. Forces create momentum. And everything that moves has momentum. And the momentum is merely transferred from one object to another object to another object to another object. And just keeps moving throughout the system constantly, always, forever. Can't really get rid of it. Except for gravity, of course. Alright, so yeah. So that's an added bonus for free. I'll give you a little extra insight. Alright, so on to trolley stuff anyway. So this guy, whatever, JPG Reggie, whatever, is playing middleman in some kind of way. Now, he posted this crap troll comment on my channel, and I deleted it because, I didn't block. I don't have these people blocked for no reason. I have them blocked because they're malicious trolls who keep lying persistently. And this particular troll thinks he owns my name, owns parts of my life. He's taken them as his property and using them. And it's not only overtly rude, it's against the whole policy of the internet. The whole point of having screen names is destroyed by people who dox other people. It's really just really anti-civil internet behavior. And if you can't figure that out, JPG, then I'm going to block you. All right? So don't post troll comments on my channel. Okay? Overtly troll comments. And you know he's a troll. And you know he's using my real name. He's doing this kind of horse shit. So, you have to do a little bit of investigating, frankly. Okay, frankly. So and it's a piece of crap as a comment, and that you should be able to figure out yourself. So anyway, let's play with it for a minute. The bowling ball problem is one that is ill-stated by Gary. No, the only thing ill-stated is the fact that you are all such despicable weasels and keep trying to, change the parameters of the experiment to suit you. And so, I have to keep qualifying to get around all your loopholes. All these ways you attempt to escape the real paradox that really exists. So let's just forget about having people. And we'll just say we have a big spring. All right. And we compress the spring the same exact amount. And then we put a 16-pound ball. And then we switch it and put an 8-pound ball. All right, what does science say happens? Same exact spring, same compression, same momentum, same energy this way, okay? In the sense of opposite equal reaction kind of thing. And so what is the consequence? Well, I say Professor Lewin would say they both leave, okay, with reciprocal velocities. This 16, this 8, if that's the number you want to pick. So whatever the velocities will be exactly reciprocals of the weight difference. So if it's half the weight, it's going to be half the velocity. Well, I guess I shouldn't draw unless I'm doing this thing. So let's just take the people out of it because they want to play some game that this is something to do with acceleration. Nobody measures the acceleration of the spring. We already know how it works. I've already explained it to you, how momentum works. The spring has a maximum velocity that might be, 100 miles an hour. That's how, if nothing's in front of the spring, that's how fast it can go. So it has more than enough velocity, okay, to give full portions of momentum to both objects. So it will fill them as completely as it can based on how much mass they have. is only this one will reach a maximum velocity of 16, and this one will only reach a maximum velocity of 8. As the momentum is fed into the mass, it has to spread it on 16 things here, you could argue, and only 8 things here, so it gives more velocity per piece of mass. The fewer mass bits you have, the more velocity it can pile on to each mass bit. That's how it works. The mass is essentially the foundation, and you're piling the velocity on top of the foundation. A smaller foundation, it means the cement goes up higher. You're just piling up the same amount of cement. So there's a certain amount of cement in here. You're going to pile it onto the foundation. And because this one has a bigger foundation, twice as big, it's only going to pile up half as high. And that's the velocity. And that's the simple facts. Again, let's understand, Newton didn't get wrong answers. He got very right answers. And he never used this stupid formula. And again, it was invented by his worst enemy in life. This is not Newton's physics, this stupid mv squared nonsense. Oh, all right. So, I mean, I don't like taking the bowler out of the scenario, but I mean, it's the only way, because they're going to keep cheating and pretending that somehow the bowler can't make his arm go twice as fast. Of course he can. And of course he would. So anyway, so you have the same force. So what are they going to say? They're going to say somehow springs don't work this way? Well, of course they do. And they certainly can't say it with any authority. They certainly can't post any link that points out how this drawing is wrong. That we shouldn't expect the 16-pound ball to be going half as fast as the 8-pound ball, when that's exactly what we should be expecting. And the simple truth is, the same force will end up creating, by the kinetic energy formula, the 8-pound ball. Well, let's do the joules just for fun. Okay. Well, let's not, because then I have to square 16 and all that kind of crap. Well, let me pause and I'll do it. Yeah. I'll do it. I'm a nice guy. Alright, should be back. Okay, so did the calculating and alright, so the 8-pound ball going 16 miles an hour, their kinetic energy formula says there's 2,048 joules of kinetic energy. For the 16-pound ball going 8 miles an hour, it's only 1,024, half as much. All right, so somehow the same force gave this twice as much energy. Now, the momentum numbers end up being exactly the same. 128 times the 2.27 for converting into joules, and you get 290 joules. Both of them have 290 joules. Kind of a sensible number when you actually think about it. I mean, I've basically stated that a joule would be a clap of your hands. So if you thought about the energy of clapping your hands, that sort of makes sense, that number. And it almost makes sense as a pound number. If you said 290 pounds, that's about what you would experience if the ball hit you. 2,000 pounds, the ball would be like getting hit by a car falling on, a car being placed on top of you, the weight of a car being placed on top of you. You think the bowling ball would be that catastrophic if it hit you? Or would it just be about 190 pounds and kind of a small object? I could see how that could be kind of annoying. It would be pretty irritating, but it wouldn't be catastrophic. So this number it certainly fits with real world experience, where this 2,000 number seems insanely exaggerated. And that's the light ball. Remember, the light ball has this insane number. But even the 1,000 is a huge, it's 3 times as much as, what I would argue the right answer that Newton would have given you. This is the answer Newton would have told you right here. If he knew what a joule was, he would have done this conversion number. This is really easy math. He would have created this conversion number. Said, oh, you want to convert from? Okay, well, yeah, no problem. Just do, this little 2.27 thing. And this is your joules right here. So, not that complicated. All right. I'm just saying it does make real world sense. I think I have the reasonable argument, and again, they have no evidence. I've shown you Professor Lewin videos. I've shown you some cart video, right? I don't know if I showed you the dropping the weight one, but there's a ton of those, so that one's just so obvious. The speed is half. If I double the mass of a moving car and I place on top of it real quick, really light, I don't drop it on, I just, just really quick, the car goes half as fast. Just a fact. Alright. In reality, you have to specify a distance over which the force is applied. So again, this has nothing to do with forces being applied. It has to do with the fact that, there's only so much energy in objects, just like there's only so much energy in a gun. A bullet has so much energy, the little gunpowder. And you can understand that, well, if I replace the bullet, okay, I shoot the bullet, yeah, it goes really fast, blah, blah, blah. Let's replace the bullet part with something else. Leave the charge exactly the same. And just put a steel rod in, connected to a bowling ball. Well, the bowling ball is going to go pretty slow, okay? A lot slower than the bullet went. A lot slower. So there's no confusion here. It's the same momentum. It's just spread over a much larger mass, so the velocity can't go as high. This is amazing that people are this resistant to something. I just don't even know how you logically understand it any other way than Newton's way. Newton didn't really talk about spreading velocity on mass, but frankly, that's exactly what it is. And the smaller the mass, the higher you can spread the velocity. Alright, applied in order to begin comparing the two balls. No, you'd have to do the experiment. So, where can you show me any experimental evidence? That's right, you can't. You haven't. Alright, if the same force is applied over the same distance, so just more of this nonsense about the distance over which the force is applied. They're the same spring compressions. The spring expands. Obviously, the heavier object, it's giving it velocity that's going to be less because it's a heavier mass, so it's going to move it slower. And it's going to move the faster, the lighter object quicker. But that's it. Alright. Then the two balls have the same kinetic energy. So again, he just says it, he has no evidence of it. There's absolutely no evidence that momentum isn't conserved in the sense that the spring compression represents a certain amount of momentum. The maximum speed of the spring is the spring's momentum. So if we knew the maximum speed at which the spring could expand, the maximum distance, then you can make that calculation, but it's still going to be dependent on the spring constant, so that fudges it a little bit. So the real thing to test is just what's its maximum velocity. And then its maximum velocity will essentially be a representation of its momentum. What is its mass, and then what's its maximum velocity? That's its momentum. That's the momentum it can deliver. If the same force is applied over the same distance, then the two balls have the same kinetic energy. So it keeps saying this kinetic energy, but different momentums. So again, Professor Lewin wouldn't say that. Okay, and so it's an overt contradiction of what happened in the Physics Girl video. So again, it's just more nonsense that somehow momentum is the breakable thing. No, it's not. So they won't post this slop. They won't tell Professor Lewin to go back to 9th grade. Because they're ballless. Okay, but they know they're going to get blocked. That's what they know. Alright, in case of the bowling ball, it's slightly misleading. There's nothing misleading except you. Because the ball swings downward before it's released. It's a pendulum. That's all. The ball doesn't swing downward in any other sense that they both are. You're taking advantage of the pendulum. Obviously, you can go higher with the 8-pound ball than you can with the 16-pound ball. But it's still just a pendulum, and you're going to push more energy into the pendulum, and that's all there is to this thing. There isn't anything more than that. And it's your extra energy, it's energy you're adding, that is going to be the important bit. And just as it's twice as light things go 4 times as high. Well, the same thing will happen in bowling, right? That light ball will go much higher. Your backswing will be much higher. But so what? Because we know the momentum is going to be the same at the delivery unless you add extra energy. And there's no place to get any extra energy from, except you doing it with as much energy as you can push into it. Alright, anyway. In the case of the ball, no, it's not misleading. Before it's released, and the force of gravity is proportional to the mass of the ball. Duh. Both ways, idiot. Going up and going down. Going against gravity. Okay. So the larger ball gets even more momentum. So there's no reason for that. No, it doesn't. There's no evidence it gets more momentum. There's no evidence you lifted the heavier ball higher, as high as the 8-pound ball. There's no evidence that your backswing was just same for the 8-pound ball as it is for the 16-pound ball. Of course it isn't. Of course the starting point of that arc is going to be higher with the 8-pound ball. So just more, you're the one distorting things. Anyway, so the larger ball gets more momentum, which is just nonsense. I mean, just think about it. He's saying the larger ball gets more momentum by some magic. By some magic. Say if you could throw the 8-pound ball 30 miles an hour, he's basically saying when you pick up the 16 ball, you'll still be able to throw it 20. Okay, not 15. Wait, we want to go half as much. Yes, 20. So instead of 15, you're throwing it 20. By some magic. You get to have free extra momentum for the heavier ball. From nowhere. Okay. For this reason. There's no reasoning here. You can verify this experimentally. So there's no experiment verifying it. So this is just an overt lie. Just keep lying, asshole. By taking a spring attached to a fixed edge and shooting a ball with it. How did you prove? When did you do this experiment? Show me it. Show me. Show me the different momentums you created with the same spring compression. Show me. Okay, as long as the spring is depressed the same distance, the two balls with different masses will both have equal kinetic energy but different momentums. No evidence exists for this nonsense. Zero evidence. He's saying the same spring creates two different momentums. That somehow the force of the spring somehow doesn't get into one of the objects. It's somehow broken and it can't push the object. It can't get the momentum into it. Bullshit. Springs are famous for being able to do this. Anyway, so he has absolutely no evidence. He just says you can verify this experimentally. Well, where's the experiment? Show me, show me, show me, show me, show me. I've shown the experiment Professor Lewin doing where, again, I mean, it's basically the same experiment because it's basically telling you it doesn't matter what's on one side. Two equal masses. They leave with equal velocities. I double one of the masses. This one still leaves with the same velocity. This one with half. That's the facts, asshole. You could just extrapolate and say, well, if I double the mass, what if I quadruple the mass? Well, the same thing's going to happen. This one's going to leave with the same energy. It doesn't matter how heavy I make the mass on this side. This side always does the same thing. That you can demonstrate experimentally. Okay, so as long as the spring is depressed the same distance, two balls with different masses, different momentums. In particular, a ball with twice as much mass will have 2 times 0.5 times the momentum, says you. So the other guy was saying 1.4. How come he can get away with 0.5? That doesn't work. That isn't correct. That can't be mathematically correct. 0.4 gives them the same kinetic energy, idiot. Alright, so that won't work. So whatever, times the velocity. Clearly just horseshit. So to fix kinetic energy, he's breaking momentum. Just bullshit. Alright, so in Walter Lewin video, the experiment is not the same as what I described. No, it's not. But it basically has within it a proof. In the sense that doubling the mass didn't make any difference. what theoretical reasoning can you apply to demonstrate that if doubling doesn't change anything, why do you think tripling or quadrupling or times a million would change anything? Answer? Oh, that's right, there won't be one. In Lewin's experiment, there is a single spring pushing two objects away from each other. Yes, and the spring is pushing in both directions. So the force is the same, but the force is not applied over equal distances. So that's, again, nonsense. Of course it is. You can't move the center of gravity of the spring, because just as I can't push into the atmosphere, the Earth is pushing me up. But pushing me up means it's merely keeping a balance between gravity and the Earth. I'm not going up, so to speak. In the sense that I'm not visually, I can't see that I've accomplished anything. And that's the same problem the surfaces have with the spring. They're in a stalemate, and they can't know that they're not in a stalemate, okay, until after the other object is all long gone. Okay, I hope you do well in 9th grade when you finally graduate 8th grade. I hope you are badgered for the rest of your fucking life, okay, as being like the consummate asshole troll. Okay, because you're wrong, and it's going to be proven that you're wrong, and you went to all of this effort merely to slander and impugn your superior, far superior, by the way. I mean, way far superior. And it's going to look really bad for you, fuckface. That's all I got to say to that. And to Stephen, the same to you, fuckhead. This is just an insipid ramble where he's still saying the staple idea was a good idea. He says, I showed heavy industrial staples weighing 69 grams pushed much further by the 28-gram weight. And I already pointed out how that experiment was so bad because the two freaking things you were shooting were different sized, you moron. I mean, it was so obviously not going to work just for that reason alone. Let alone, where did you ever demonstrate that staples aren't like look, even a piece of wood, I have pointed out, you retard, that this isn't that simple, right? You can have a simple piece of wood and some karate guy can hit it hard and fast, split the wood into two pieces, okay? The pieces fly off over here and over here, and he'll use less frickin' energy than if you walk up to it and slowly apply pressure, apply pressure, apply pressure, and you won't break the wood, and you'll just sit there and use up a lot of energy getting absolutely nowhere. Alright, so these are the facts. Every substance, you have to test it to figure out whether or not it has a bias for velocity. Clearly, wood has a bias for velocity. It has a snap point, and if you can go above a certain velocity, you're going to go through wood for free, almost. I mean, it's going to cost you very little. Cinder blocks. There's karate guys that put cinder block on top of another cinder block, 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 and they just go bang with their elbow, poosh, and they break this one, and break this one, and break this one, and break this one. All the same energy breaks each block. They never even use more than one hunk of force. The same force broke this block, broke this block, broke this block, because of momentum, you idiot. If they go fast enough, when this one finally does break, this piece goes fast into this piece and fast into this piece and does the same thing and breaks the next block. It's because of the speed. The speed is a huge bias. So you go slow, you break your arm. You go fast, you break the blocks. Clear bias, you moron. I mean, I've been over this and over this and over this. So he has a row of fucking staples glued together, right? And all of a sudden he thinks this is the greatest test instrument mankind ever created. Look, this is so fantastic. Of course it equally moves. What do you mean, of course? We don't know anything about how the glue or how they're attached or, what the real binding thing is here. We're bending a piece of metal that they're attached with, a common piece of metal they're all glued to or something, or soldered to or welded to. Who the hell knows? So it's just this weird thing. And then, like I said, overtly in his experiment, the fast thing was about, 33% smaller than the slow thing. So the slow thing was given a huge disadvantage in that it was much bigger. So obviously it's going to hit a wider surface area. If a karate guy does that, he's not going to break the piece of wood. That's why he has to try to hit it with just his knuckles or some kind of small area, because he wants to fracture it. He wants all the energy to go into one place, not spread out, you retard. So of course, if it goes into one place, it's going to move these staples, which are going to force and drag the rest of them along, blah, 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 blah. But again, you want to defend it, go ahead and defend it. But you haven't defended it with anything called reasoning and logic. You have no good reason to believe staples are a good way to test something's energy. You have no reasoning. You're just doing it because, well, it's a cool thing to do. But you have no way of knowing because you haven't tested it. You haven't found out whether it has a huge bias for velocity. And then again, you tested it with a prejudice built right into the experiment that was obvious. It was visually obvious. I can't believe in capital letters he's defending that horse shit. It's just, what's the point? Okay, Steve, you have said springs are a cheat. Why don't you explain how springs don't work? Explain how, when a fast thing hits a spring, it gets 197,000% hotter. Okay, so when fast things hit it, it gets too hot and it loses all its energy. Give me some theory. Okay, but there isn't any. The fact is, these speed differences aren't going to make the spring 50% hotter or some other kind of dopey crap. There's no evidence that any of that happens. You don't see it as any kind of deformations or any other kind of aberration that happens that could indicate you're losing energy somewhere. Springs are pretty reliable. Okay, you don't like springs. Well, then come up with something better. But don't tell me I have to like staples. That staples is automatically a great idea when I don't know anything about it. I have never seen it used before. How the hell can I tell you whether or not it has a bias for velocity or not? Of course I can't. But I can certainly point out that, well, where did you demonstrate that this is a good way to collect energy? I'll point out again that the best way to collect energy, that is to test for energy, is with devices that store energy, not devices that don't. Devices that fracture indicate they're more likely to be suspect because of heat and different things, and they're going to yield to velocity. Where devices that store means they're not as likely to have losses. They're not as likely to have places where the energy is lost to heat. That's why it's storage. It works. So devices that store are probably going to be better at collecting energy than devices that don't store. Better at measuring energy. So what is wrong with that argument, fuckhead? I mean, all of this obnoxious twiddle, all this capital letter crapola, okay, because you don't want to accept what it takes to be a scientist. That is, you actually have to have a credible argument. Then another thing he gripes about in here is the weight. He says, well, you didn't ask Professor Lewin to weigh the trains. Well, obviously, I'm quite sure that he did. And, obviously it's a premise of his argument. And besides that, it's not, frankly, I didn't ask you to weigh the coins, did I? I asked you that you have to be able to measure their velocity. The whole point is you have to be able to send the two objects at inverse velocities. One has to go twice as fast as the other. So you have to have some evidence that you've achieved that. You had kind of a flimsy, flaky little way of creating the velocity. It didn't look terribly consistent to me. So what's your argument that somehow you're absolutely sure because you say so? I'm saying I didn't see so. And it's really quite important. I mean, you were talking about a little bit of a change makes all the difference here. The bigger the object, the less errors like that are going to be possible, but the smaller the objects are, the more the errors count. So, you do have to get that kind of shit right. And the simple truth is I believe the spring experiment showed the truth. You believe the spring experiment showed a lie. I believe it showed the truth. And the other experiments are the ones that are flawed. Now, you believe the opposite. I don't think you believe it for any good reason besides your hatred of me, which is fine, but I'm going to make the argument that the other experiments did have obvious flaws, and one of the most egregious is you never established velocities. At least the spring establishes a reliable velocity. I can believe that if you compress the spring the same amount each time, it's producing, relatively speaking, pretty close to the same amount of energy each time. So that was a pretty reliable way to impose the force. You can't understand why somebody could see that one as being kind of, well, you don't have to prove it because it's the same spring compression. But a lever? Oh, come on. Unless you've tried and trued it, there can be all kinds of irregularities that you didn't account for. So, anyway, this is, like I said, it's not worth reading. It's just miles and miles of just gratuitous ad hominem crap for which he has no evidence and has never proven and blah, blah, blah. They're just all his little wacky stories that he lives for, but they're all that bullshit, lies, nonsense. All right. I see, he says right here, why did he have no complaints about friction in the one test that suited him? I talked about it in that one too. I pointed out how they don't look like they're rolling, which isn't great. So it's just an overt lie. I talked about friction throughout the whole video because it didn't look like you did much to negate friction as a problem. And as I pointed out, friction hurts. Friction on surfaces hurts the heavier object more than it does the lighter object because of gravity. Because we're in gravity, it's a prejudice. So if you don't eliminate for friction, if you don't minimize friction, it's going to hurt the heavier object more. Fact, asshole. Shit. So you don't think I have a right to point that out? It's directly could be a cause for the flaws in your experimental results, could be exactly picked on that exact fact that you've decided to do the experiment without an air track, without mechanisms to reduce friction, and you're claiming it didn't hurt the results any. And you think it's irrational for somebody to point out to you that, no, I don't think that's exactly how reality works. Friction's a problem. That's why good experiments are done to eliminate it as much as possible. And shitty experiments are done, where they don't recognize that it could taint the results. And it can, quite easily, especially when you're comparing two objects that are affected by friction inversely. Idiot. Alright, so that's probably enough of this crap. More crap, capital letter crap. So in his other comment is where he points out, well, man, it sure is going to be embarrassing if Gary's right. So I thought that was a funny concession. I will leave you in peace now. So whatever this horse shit was. I mean, that's why not a single person in 3 years has been bothered to ring around, for instance, a radio ham, etc., to find someone qualified to do Gary's pathetic radar experiment that I have already done. So he didn't, many times over. No, he didn't. So it's just an overt lie. You haven't done the radar experiment with the detector in the middle, and you didn't do the radar experiment where you just, put a directional antenna. Just make sure that you can direct it and just turn your little horn right to one of the sources and right to the other source, and if you can hear them at the place that's supposed to be canceled, well, that means it didn't interfere in the space between the surface. You didn't do that experiment. Liar. Fucking liar. insipid, stupid liar. You should just do, I would have never, if I had had my choice, this experiment would have never been done with those. As soon as he told me that he was getting these stupid radar dishes and they have some fucking diode in them that forces them to be one frequency, I already pooed on it. I told him, well, that's not good, because it's a gimmick. Okay, you're not really able to detect any frequencies or any kind of radio, because the diode has to be triggered by it has to get into an oscillation. So that fucks it all up. I mean, so just don't use 5 gigahertz or 9 gigahertz. Tone it down to 2 gigahertz and just do it over a larger space. I mean, even if you did it over 15 feet, at say 2 gigahertz or 1 gigahertz, you could still detect at least 2 or 3 fringes, and that would have been the way to do it. Well, anyway, there's no point in talking to this lunatic. And it's also safer. And then his frequency generator that he bought 2 of, for whatever reason, right? Then it would have been able to, you would have been able to go from the 1 gigahertz signal and see if you could detect the 2 gigahertz signal I predicted would exist. In one perfect location, there's a 2 gigahertz signal where the two interfering waves are 100% out of phase. And so it's essentially doubling the frequency. And I say that would be detectable. It's a very small band, but it should be detectable. Well, anyway, I don't want to go into that. He did shit experiments. Go just watch some of his videos. You see the shit experiments he does. He does shit experiments. Middle of the night, blah, 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 slop ass tape here, slop there. Just forget it. I mean, just all that equipment to waste because he wouldn't do what I suggested. He said, I'm doing it my way first. I mean, right from the very beginning, the first thing he did was, I'm going to repeat their experiment. Well, why would you repeat their experiment? We've already seen their experiment. We want to do it different. We don't want to do it the same way. We've already seen it done that way. And it was like, what the fuck? All right, anyway. Yeah, these people are just people. Ugh. God, I just hate humans. Ugh. But yes, it is disappointing. See, the clear fact is there just aren't enough people in this conversation. So we don't have enough. All the other dissidents are trying to do their own thing. And so they don't want to be part of somebody else's physics arguments because it's not their physics arguments. They don't gain anything by being part of some other person fighting for their truth and all that kind of stuff. It doesn't do them any good. So there's just not enough of them interested in other people's theories because they're too obsessed with their own. Now, I do, I'll watch the D. Hilsters and I'll watch the rope guy, Bill Gates, and, I'll watch the even the ones I hate, Fractal Woman and Ken Wheeler and, stuff that's really hard to watch. And because, if they have an idea, great. But, there hasn't been anything. I mean, it just almost nothing. I mean, the one guy did okay. What was his name? Let's see. Sort of a Tesla nut. Sort of believes some of Ken Wheeler's shit has some merit. But he does argue some of it. DeCinti. Yeah, DeCinti. Yeah, somebody asked me who made videos that were PowerPoint presentations or something. It might be that guy, DeCinti. But anyway, what was I saying? Yeah, he did some polarization, videos that were sort of interesting, but it was all wrong theory. But there were good demonstrations, good experiments. And that's the part that everybody needs. We need more experiments. All these, I've sent a couple of emails to a couple of colleges trying to solicit them to do experiments that matter instead of the same shit they've been doing for 50 years. I mean, unfortunately, as I found out, every single one of Professor Lewin's experiments was done in the 50s. It's the same fucking experiment. Even the one where he shoots a monkey off a stick. They did that. They shot a monkey off a stick. 50 years ago, 70 years ago. So very disappointing, that they really don't. They have all this equipment and they don't do anything with it. They don't test any of this stuff. And that's just sad. Sad for college. It's not the place to go to learn, because they don't. They're just reading out of their Bible. Do the standard shit that makes it look our way. Don't ever do it off. Don't run off the reservation because you might see something that'll give you some doubt. It seems that's pretty obvious. But anyway, I mean, even just the simple one. I mean, nobody has thought of just dropping a stick of butter 1 meter and weighing it. What does it hit? With what force does it hit the scale? I mean, fuck, that's a joule. You can just easily convert joules into pounds by just dropping a stick of butter onto the scale and seeing how much it weighs. And now we can just call it all pounds instead of joules. I mean, fuck. But anyway, so whatever. This is just, you people are just so obnoxious. So anyway, there is a photon question that was sort of interesting on Quora that I did answer anonymously, but nobody's reading it, so that's unfortunate. But it's not a bad answer, a little concise hunk of the physics. And I just, it'd be interesting to get some reactions from people just to see how they react to the argument that there's a better way to understand a photon. But anyway, we'll see. So, I guess there's the point for you, JPG guy, is that we've sort of isolated the disagreement, right? In the sense that we could just write a statement about different spring compressions can create different momentums. I mean, the same spring compression can create a different momentum depending on what I put in it. So, like a bullet in a gun, if I put a heavier bullet in, I can create different momentums. Okay, so I can make the heavy bullet actually gain more momentum than the light bullet. If I put a heavy bullet in, I get more momentum than if I put a light bullet in. Now, obviously, I say that's horseshit. It never happened in the history of mankind. But this is the real test, right? Because they're saying science says, when sure, there's plenty of physicists who will concede that it's the charge you're putting in the gun. Okay? That's the thing that's important, not the size of the bullet. Yes, the bullets will leave at different speeds, but they'll always leave with the same momentum. And that includes the bullet that weighs as much as a bowling ball. Always the same momentum. Alright. Because momentum is the force. Again, if Newton was alive today, he would simplify all this for you by saying, I should have done it, right? I didn't know the word energy. And we just had a vague notion of force because we really hadn't done heat yet, and so we didn't have a very complete theory. But I should have said to you, F equals E equals mv, because that's my physics. That's Newton's physics. Momentum is, the force is momentum. All you can do is exchange it. All you can do is give it away to things. That's it. That's all you have to give. If something's moving, all it has to give is its momentum. It doesn't have any other kind of energy. It just has its mass and its velocity. And that's all there ever was, and that's all there ever will be. And this whole thing is insane, that you people are defending physics that doesn't have any experimental evidence defending it and is logically silly. It creates so many paradoxes. And here you are just defending it because it's your Bible and for no other reason. Something this poorly evidenced, how can you have such confidence when you can't show me one fucking link to an experiment where you collect this extra kinetic energy, or where you show the lack of momentum? Where you show momentum not being conserved, or you show the collection of your extra energy. You don't show any evidence, any physical evidence that either one of those two statements are true. That there is such a thing as extrakinetic energy, or there is such a thing as uneven momentum. Zero evidence. So this has been a DraftScience video presentation. Till the next time and such.